Welcome to Daily Papers,
the podcasts where we dive into the latest research and break it down into something you can actually use to sound smart at your next dinner party.
Today, we're looking at a fascinating paper that's essentially trying to build a smarter study plan for artificial intelligence. It's called DreamPRM-1.5, Unlocking the Potential of Each Instance for Multimodal Process Reward Model Training.
That is a mouthful, but the core idea is simple. What if we can teach an AI not just by throwing a giant textbook at it, but by acting like a great tutor who knows exactly which practice problems are the most helpful?
And it seems to work. The AI they trained with this method is acing its exams, even outperforming some very powerful models, including something called GPT-5 Mini.
Okay, so before we get to the results, let's set the stage. The paper is focused on training multimodal AI. What does that mean?
Multimodal just means the AI can understand different types of information at once. Think about how we browse the internet. We read text, we look at images, we watch videos. A multimodal AI can do the same. It can look at a complex chart in a business report and understand a text question about it.
So, to teach these AIs, scientists feed them massive amounts of data. Millions of examples of images with questions, diagrams with explanations, and so on. But this paper highlights a huge problem. A lot of that data isn't very good.
Exactly. Imagine you're trying to learn a new language using every single resource on the internet. You'll find some brilliant lessons from expert teachers, but you'll also find a lot of confusing blog posts with typos or sentences that are way too basic to be useful.
If you treat all that information as equally important, your learning is going to be slow and messy. The bad or trivial examples end up diluting the good ones. The AI gets bogged down by the noise.
And this gets even trickier when you're trying to teach an AI not just the final answer, but the process of getting there. You want it to learn how to reason step by step.
Which brings us to the first key concept in this paper, process reward models, or PRMs.
This is a really cool idea. A traditional AI model is often trained to get the final answer right, and that's all that matters. A process reward model is different. It's like a math teacher who gives you partial credit for showing your work.
Right. The PRM looks at each step of the AI's reasoning. It gives a little reward for a correct step and a correction for a wrong one. This encourages the AI to develop a logical, step-by-step thinking process, not just guess the answer.
So that's the how of teaching it. But the big innovation in DreamPRM 1.5 is about what it learns from. This is where the smart study plan comes in. The authors call it instance reweighting.
Instead of treating every training example equally, this system learns to give each one an important score or a weight. The really helpful, high-quality examples get a high weight, meaning the AI pays a lot more attention to them. The noisy, confusing, or trivial examples get a low weight, so the AI basically ignores them.
So how does it know which is which? It uses a really clever feedback loop that the paper calls bi-level optimization.
That sounds intimidating, but we can break it down with an analogy. Imagine you have a student and a tutor. The student is our main AI model. Its job is to study from a huge pile of flashcards. That's the first level.
Now, the tutor is the second level. The tutor's job is to watch the student. After a study session, the tutor gives the student a pop quiz using a small set of hand-picked, high-quality questions that the tutor knows are excellent for testing understanding.
Based on how the student does on that quiz, the tutor goes back to the giant pile of flashcards and starts reorganizing. They might say, okay, these flashcards about biology diagrams are clearly working. Let's give you more of those. But these ones over here with blurry pictures are just confusing you, so we'll put them at the bottom of the pile for now.
It's a constant cycle of study, test, and then reprioritize the study materials. The system automatically figures out which data is educational gold and which is just noise.
Without a human having to manually sort through millions of examples.
And the paper actually proposes two different ways for the system to manage this reprioritizing. The first is called instance table.
This one is very straightforward. It's like the tutor has a giant spreadsheet with every single flashcard listed and a column next to it for its important score. It's very precise and works great for smaller sets of flashcards. But you can imagine if you have a library with billions of books, that spreadsheet becomes impossible to manage.
That's why they also created InstanceNet. This is the more advanced strategy for huge data sets. Instead of a giant spreadsheet, the tutor is now a super fast assistant, a mini AI or a net that can just glance at any flashcard and instantly predict how useful it will be.
It's like a librarian who can tell the quality of a book just by looking at its cover and a few pages, instead of having to look it up in a massive building-sized catalog. It's much more efficient and scalable.
Okay, so the theory is great, a personalized AI tutor that creates the perfect study plan, but does it actually work? How did it do on its final exams?
It did incredibly well. The researchers tested it on a benchmark called MMUU. You can think of this as a very difficult, multidisciplinary final exam for AIs. It's got college-level questions from science, art, business, and more, all involving complex images, charts, and diagrams.
And the results were pretty stunning. The base AI model before using this smart studying technique scored about 80% accuracy. After being trained with DreamPRM-1.5, its score jumped to 84.6%.
That's a huge leap in the world of AI. That score surpassed several other powerful models, including a baseline built on GPT-5 Mini. So the big takeaway here really is quality over quantity. It shows that just having more data isn't always the answer. How you use that data and your ability to filter out the noise to focus on what's truly valuable makes all the difference.
By creating this dynamic feedback loop, the researchers gave their AI a better way to learn. They taught it how to study smart, not just hard.
A lesson we could probably all learn from.
That's all the time we have for today. Thanks for tuning in to Daily Papers.
Join us next time when we unpack another big idea from the world of research.